but over the centuries this view has changed drastically. We eventually learned about our solar system's existence and our Milky Way galaxy. Later, we discovered that our universe was filled with other such galaxies. But it could be that we're committing the same error as our ancestors by thinking that our universe contains everything that there is. The word multiverse refers to the general idea that our universe might not be unique at all, and there may be other universes out there that defy all of our laws of nature. What is known as the anthropic principle is the idea that our universe is fine-tuned to allow humans to live. A small fiddle with the strength of gravity, for example, and life as we know it would not exist. A coincidence that does not sit easily with scientists. The concept of a multiverse neatly addresses this problem. With the infinite number of universes that could exist, we are simply living in the one that we are only able to, meaning that other universes, depending on their laws of nature and physics, could have very different biological life forms or maybe even paranormal entities. And then there's this theory, which is quite hard to put into words, so I will just keep it short. There are many universes, and everything is the same inside each one, meaning you exist on every single Earth. However, each outcome of your entire life is different. Whether you fail school or become top of your class, the jobs you receive, the people you love or lose, and any decision you've ever made or chose not to make would have a different outcome throughout your life. But unfortunately, we are only one human with only one outcome on this planet alone, meaning we could never actually prove this multiverse theory to be true, because no matter what, we are stuck with the outcome that we're going to have on this version of the universe. And the chances of one of those outcomes successfully proving this theory, unfortunately, are very remote.
Stop.
Number 4, a supernova. A supernova is a massive explosion generated.
Where did this theory even come from then?
Multiverse theory?
Yeah, or us being on one version of ourselves on every Earth in this multiverse.
I don't know about that.
That seems like a comic book theory. Like,
Yeah,
I'm going back to Morty
that.
and Marty on that one.
Yeah, Rick and Morty, yeah.
Yeah, Rick and Morty, Morty and Marty.
The multiverse, yeah. And I think it's just assumption.
You know, because I've heard another...
Not even really educated guess, really.
Right, it just seems like to the left. What do you think, bro? Sci-fi? Yeah.
Yeah.
Right, because if
because like if it's saying that if it's already proven that this is the only universe for Earth, and what this gentleman just said, like we don't even have the ability to live somewhere else. Like there's no way that we can prove that actually exists. So like where do you get that from? You get it from sci-fi, make believe. Like someone was like creative enough to put that out there.
Yeah, I'm going to have to do some research on that one. And back to the concept of theory. I need to refresh my memory refresh my clarity on the concept of theory and how it's probably changed as well. That's important.
Because even if there is another Earth somewhere, who's to say that they breathe air? They may breathe ammonia. You know what I mean? Who's to say? So you don't really know. And there's no real way of knowing until hundreds of generations in the future.
Or if there is something like that and scientists aren't sharing it, just like how there's so many probably supposedly cures out there already that is not being shared because of funding.
Yeah.
You know, because of money, right?
Chris Rock used to say,
you know, there are aliens that we have encountered on Earth, but you know, supposedly us as humans aren't ready for that. So scientists, you know, and the government and you know, they hide that from us, the FBI, right? Mm-hmm. Supposedly, so.
Because haven't you wondered how, since let's say 1985, how technology just moves so fast from 85 to now? You know how fast technology because we went from beepers to having computers in our pockets in no time.
Yeah, but then at the same, yeah, I can get what you're saying.
And military's probably been using it for a while, and now they're saying, all right, we got what we can get out of it. Let's give it off to the public so we can make money off of it now.
Right. And I did actually watch something like that. Like for example, condoms was a military thing before, and it wasn't used for sex. It was used for something else. I don't really remember, but it was a lot of things that that we use as consumers every day now, it did start in the military, and
Like
it was
the internet.
practiced and used right. And then you're right, Troy. It was like, well, we need money, we need funding, so let's start putting it out there, commercialize it, right, and tweak it for the public.
And these dummies will give us all their information. We don't have to hunt for it. They'll just give it to us. Because they're vain.
Right.
They know the public is vain, and everyone stars for attention. Everyone wants to be the star of their own show. So give them this, and they'll just give us all their information.
But now it's to the point where you can't move forward in certain resources that you need or applications that you need to use without the vanity part, because they want your information.
Right.
Oh, this platform accepts cookies. If you don't agree, you can't move forward.
Right.
Or
Yeah.
this application needs to take your pictures and your photograph. Sometimes you do need it.
How bad do you want it? Are
Like,
you willing to give up something? That's the same thing with 9/11.
Well, like the app Zoom that I have. I have to use that for my classes that I take right now online. I have to, because that's the platform that they set up for me.
Yeah.
Would I rather us just call each other to do a conference call like we have on our phones, direct line to line? Hell yeah. But you know, and now I have to update it. So every time you make that update, it reinstalls the app and gets more information. And you know, it's like, damn, you know.
And you're right though, Troy. I mean, both of you guys, because it's like, it's a choice in the beginning, but then it gets to a point where they force you into it because the whole world is changing, and so you have to change with it or you're left out.
And I resist it as much as I can.
Yes,
you notice
you did.
I resist as much as I can. I don't do social media. Like I say, to me it's mental masturbation. But I'm just not willing to give out my information so freely. I'm just not willing to do that. Just not willing to do that. If you want to know something, you're going to have to ask me.
Right.
And I might tell you and I might not.
Right. Amen to that. Yeah.
Okay.
Let me know when you're ready.
Yep, let's do it.
Let's go for you. Queen of notes. Well organized and thought out. Ready?
Yep.
Hit by a dying star. A star in our galaxy goes supernova once every 100 years. The explosion hurls matter into space and can shine as brightly as an entire galaxy for short periods. Stars are giant nuclear reactors producing energy by fusing hydrogen into helium. Eventually, however, stars run out of hydrogen to fuse. When this occurs, the star begins to fuse helium into heavier metals such as iron. The star's core shrinks while its outer layers expand, creating a red giant that consumes surrounding planets. But what happens when the sun runs out of helium? Fusion simply ends in small stars like our sun. The star becomes a white dwarf and slowly fades away, but when a large star depletes its helium reserve, the core collapses within seconds, causing temperatures in excess of 1 billion degrees Fahrenheit. The outer layers of the stars collapse as well, only to explode outward in a massive explosion known as a supernova. What's left of the star's core becomes a dense neutron star and forms a black hole, an area of such densely packed matter that not even light escapes its gravitational pull. After a supernova, material expelled in the explosion may form nebulae, which are massive interstellar clouds of gas and dust. Over millions of years, gravity pulls nebulae material together into a dense, hot core called a protostar. Protostars eventually become newborn stars, and the newborn star's gravitational effects surrounding the nebulae material over time may form asteroids, comets, and even new planets. It is truly the circle of solar life. Number 3, the dark flow. The eternal dance of light in the night sky has fascinated humankind for thousands of years, given birth to gods, myths, and finally to science. But now there are hints of strange movements in the heavens. If they can be verified, they will be first hard evidence that there is an edge to the universe. Sasha Koshlinsky is a NASA astronomer. He claims to have detected a pattern of movements in the heavens so bizarre that it could revolutionize our theory on the universe, just as the Big Bang once did. Sasha wanted to check more precisely how fast and in what direction galaxies are moving to see if there might be any subtle deviations. He used an effect that can only be seen when clusters of galaxies are colliding. The gases around them get heated to millions of degrees. When light from the cosmic microwave background passes through a hot gas, it gets subtly altered. How much it changes depends on exactly how fast the gas and the galaxies it surrounds are moving. Sasha continually and methodically checked this data for over a year, and his data showed something unbelievable. All the galaxy clusters, no matter where they were in the sky, were all veering off to one side of the universe. It was as if they were being pulled towards a mysterious attractor beyond the visible edge of the universe. He called it dark flow. What do you think it is, and where is it pulling us to? Number 2. Supermassive black holes. In nearly every large galaxy, astronomers have found evidence of black holes millions, even billions of times the mass of the Sun. As I spoke about supernovas in number 4, black holes form from what is left of a star's core after it has gone supernova. The collapsed core of a dead star implodes, and its weight is enough to squash all the atoms right down to their nuclei. The result? An ultra-dense ember called a neutron star. The density of a neutron star would be like taking a mountain and crushing it down with so much pressure into the size of a marble. Neutrons can withstand incredible pressures, but if enough matter falls onto them beyond a critical threshold, they can be crushed down to nothing. When that happens, a black hole is born. A black hole is gravity taken to the extreme. Its mass is literally packed into a point and enshrouded within a dark sphere called the event horizon. That sphere is the point of no return. Any gas, stars, planets, or even light that falls in disappears forever. Albert Einstein said that gravity is not just the attractive force of planets or stars like the Sun. It is a warping of space and time, what scientists call space-time, with the presence of massive objects. With the mass of a star squashed down to a deep point, a black hole is basically a deep puncture in space-time. If a future explorer prospecting for data tempted fate by traveling too close to a small black hole, they would be ripped to shreds immediately. However, a supermassive black hole has more spread-out gravity. The ride would be much smoother. What you'd find if you made it inside is the most extreme destination in all of the universe. Number 1. Further speculations and philosophies. So what do we know? Honestly, not much, and won't, not for a long time at least. A time that expands so much farther after yours and my own lifetime. The real question is can we figure out everything there is to know before Earth is destroyed by some random, miraculous, terrifyingly beautiful act of this thing that we call the universe? After watching this video, look up into the night sky and allow yourself to see more than you did before. Do not feel small, insignificant, unimportant, or pointless. Instead, thank your eyes, your brain, and your body, your own silent companion throughout your life, for allowing you consciousness at such an extraordinary time period where you and your fellow man can study these mysteries of existences that are so far away. And whatever you believe in, don't allow this video or others to ever discourage that belief, whether it be gods, science alone, aliens, the paranormal, or nothing. Instead, combine the knowledge we do know of with your own beliefs and theories to see what depths of your own mind you can then explore. We too, as human beings, are made up of the same stuff of galaxies. Maybe we're not supposed to know. Maybe the true meaning of life, while you have it, is to simply give it some meaning.
Just live it.
That was beautiful.
Yeah, that was great.
And I do believe in that.
Thank you so much for watching, everyone. I hope this video made you think a little, learn new things, and have some new questions. If any of that happened to you, please take a couple seconds to give this video a like, as it really will get it out there for others to see it too, which would really help me out a lot. I had such a wonderful time making this video, and it actually helped me let go of a lot of struggles that I've been dealing with in my own life, and I hope that it can do the same with you. Follow me on Twitter and Instagram to keep up to date with the latest videos coming out on this channel. And if you know what I should count down next, post it in the comment section, and I will definitely make it happen. Have a good day or night. Thanks, guys.
Peace.
Interesting.
Yeah. So all the little things that we deal with down here, all the wars and basketball games, football games, lemon hip hop, all this other kind of insignificant stuff. Just do stuff to make you happy and to spread joy to the people around you, and try to minimize conflict as much as you can. That's what I say. Because you're going to have conflict with people sometime. You just minimize it and keep it to where it doesn't have to always affect your day-to-day.
Yeah, now I'm more curious about how we're reflections of the galaxy, like just with our makeup, and going back to other videos we watched with the science and the mathematical
Equations and
that is life,
yeah.
and everything inside of a flower, that's inside of a tree, that's inside of a person, that's inside
it's
of
all
Earth.
mathematics.
Yeah, it's all mathematical. And I'm more curious to see the complementary aspects of the human body and the galaxy. So
because they say as above, below is the same thing. So when you see like a spiraling galaxy, most galaxies, I think it's kind of rare for spiral galaxies, but most galaxies that you see have the little spiral in it, and then you look at your fingerprints and stuff, and it has the spiral, the seashell, and the flowers. So as above, below.
Yeah, that makes sense.
Yeah.
Now, I don't understand space-time, because of the whole theory in terms of like how time gets warped, I guess, in a black hole or in space and all of that. But it's like, if space is so different from Earth, right? Like, how does the time in space connect with the time on Earth? Unless I'm like totally thinking in a different direction about it.
Space-time, if I'm not mistaken, was born when the Big Bang happened. When the Big Bang happened, that's when space-time came into existence, I guess. And we look at time a little bit different, but like he said on here, Einstein looked at space as being like a fabric. And like the planets and stuff and the black holes, like he was talking about, can fall on that fabric and push it down. Like if you had like a paper towel in your hand and you put a chip or a salt shaker or something, it's going to bend it a little bit. Mm-hmm. So I think space-time is something that you can't have one without the other. You can't have space without time. You can't have time without space.
But that still doesn't, I don't get that. Because to me, when you use the paper towel example, like, to me, that's a gravity thing. I don't see that as a time thing, unless I'm,
Well, when things like when he showed that little grid where it had the planet making its small little indentation and the sun was making a bigger indentation, as they move, because they're actually in motion, and people think the planets go around in like a circle, but they go in a elliptical circle, but I don't think the planets actually just move like this. I seen a video to where they said the planets move like this. They move in like little loops around while they're moving. So in those movements, you're taking up space, and it takes time for it to make each little circle. So that's time right there to me.
Yeah, but isn't it comparable to, like, the same time? Like for example, like you have like, I hope this analogy works. You have a slow car, you have a fast car, right?
Yep.
Fast car is moving of course, obviously faster than the slower car, but they're still moving
in the direction.
In the same, right, at the same time. One is just going faster than the other, but the time isn't changing. Now, maybe the destination, the time of the destination is going to be different because the fast car will get to the destination faster than the slow car, but it's still same time.
Yeah.
Like, the time isn't changing.
The time is changing for the faster car because it's going to get, say both of those cars are trying to get to the same destination.
So the distance doesn't change.
Yeah.
But the time changes.
The time changes because the faster car is going to get there quicker than the slower car. So that's a time difference right there. And the space is the direction that they're both traveling. Say you're trying to get from one city to another, so it takes time to get there. So that one car is moving faster, it's going to get there in a quicker time than the other car. And that whole distance that they took up space. You get me?
I get that.
Like 1 mile.
But and to me, I'm thinking like the time still stays the same because it's still like
no.
1, 2, like the way I'm receiving it is 1, 2, 3, 4, 5. Both cars are still going 1, 2, 3, 4, 5. It's just the fast cars, right. Well, the slower car is going 1, 2, 3, 4. That's why, but it's not like that.
And 1, 2, 3, 4, 5 will be the distance versus the time it took to get through that. The time that each car took to get through the distance, 1 through 5.
Yeah.
Okay.
And then 1 through 5 is the space, because that's the distance in space, and then how fast the cars go.
One goes
50 miles per hour versus 25 miles.
Yeah, and the other ones go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5.
And the time it took was 10 minutes going 50 miles versus 20 minutes going 25 miles.
Yeah. That's time and space. Yeah.
Okay.
A hell of a math equation. Back to math. Good stuff, you guys.
It's just interesting.
They're one of my strong subjects. So.
Maybe if you go on like YouTube or something and start watching stuff like how the universe works, and you'll start getting like some. It'll get you more acclimated. Like I was telling you a time ago, that's how I fall asleep. I turn my television on to like how the universe works. My TV has a timer. I say 40 minutes. I should be sleeping 40 minutes. So I listen to all this space stuff while I'm sleeping. So that's probably why I can retain some of the stuff that I've learned, because I listen to it almost every single night. I listen to science stuff.
Right. And I am a visual learner, so I need like, the visuals to understand them. But yeah.
And like always, you guys, please leave your comments below. Give us some feedbacks, give us some tips and resources that we can, educate us, tips, and give us some resources where we can develop our questions and our knowledge and our intellect regarding science and the planets.
Because I know I didn't get everything right, so enlighten us on whatever knowledge you guys have out there. We'd appreciate it.
And if you could give us a better explanation of the time and space concept for my sister, that would also be great.
Thanks.
No, seriously, because
put it in crayon, because she's a visual learner. No.
Subscribers, you know what I'm saying. Where I'm coming from. You guys have my back on this one, okay?
You know what I was thinking too, guys? I was wondering maybe since scientists are and people are going out to space, astronauts, all of them are trying to find life in space. What about creating it? Like taking the elements from and the materials from these planets that we visited before, and see if we could combine stuff like science. No, it's
like trying to do that with Mars.
And we're already on the cloning phase. It's just like, why not take the natural elements that are already there and see if maybe that is what will create the life that we're trying to see? Because it's already life there.
Colonization, Avatar?
No.
She's talking about playing God on another planet.
Well, no, because I'm just wondering too, like, what if something as simple as like the liquid sets on the planet, if there are any, the gases that are there, the grains that are there, the minerals, thank you, and you just simply like do put in a little, science lab, and then see if that will grow something or create something. That's what we do with plants anyway. They
probably do that now.
They
probably do that now.
That's one of the reasons why they're trying to get to Mars and bring our resources there and collect them to see we can live there.
Right, because we're on migration.
Huh?
Mm-hmm.
So probably another good reason why Monsanto's, that's how you say that? Monsanto, the seed company,
Yeah.
that's why they're keeping all those seeds, because they probably want to do something with them later.
Outside of controlling our
Food and
farming.
and our air.
Yeah,
and,
food, farming, air, all that stuff.
Yeah.
But yeah, absolutely.
Great video. We enjoyed it. Hope you guys enjoyed it. Don't forget to like, comment, subscribe, and
Follow our social media. Hit that notification button.
And come back and see us again, and we'll see you next time on Talk TV.
Peace.
Peace.